So we want to resolve this problem. The square root of t to the power of 3 equal to the square root of 3 to the power of 3. So for us to resolve this, we'll be taking a step-by-step process until we finally get our answer. So let's remember the rule that says if the square root of a equal to a over 2, then if we apply this particular square root of a to equal to a to the power of half, if we apply it to this, we'll then be having t raised to power 3 to the power of half equal to 3 raised to power 3 to the power of half. Then let's also recall that in indices, if a is raised to the power m and further raised to the power n, then this is equal to, is the same as a to the power of n further raised to the power of m. So we are going to be applying this particular rule to this equation. It will then give us t to the power of half. That's, we reverse this, m to the power of n, and we reverse it to n to the power of m. So the same way we have t to the power of 3 or to the power of half, we are also going to be reversing it. So this will now be t to the power of half further raised to the power 3 equal to 3 to the power half further raised to the power 3. So this will now give us the square root of t all raised to the power 3 equal to the square root of 3 all raised to the power 3. This implies that the square root of t to the power of 3, this particular one crossing over becomes negative square root of 3 to the power of 3 or equal to 0. But recall, if a to the power of 3 minus b to the power of 3, this is the same as a minus b bracket a squared plus ab plus b squared. That means whenever you have a cubic equation, you can actually resolve it to a linear equation and a quadratic equation. So remember, our equation is this was the equation we got. So we are going to be making this equation to look exactly of this form. This implies that all squared, that is for this, plus root t square root of 3 plus square root of 3 all squared. So close the bracket. So this and this now look alike. Let's keep breaking it down. So this will become square root of t minus square root of 3. Resolving this, we have this square cancel this square. We now have t plus root t3 or 3t rather plus 3. So this will cancel this. Remember, all this is equal to 0. It implies that the square root of t minus the square root of 3 is equal to 0, and t plus 3t plus 3 is equal to 0 as well. So for us to get the solution to this problem, we'll resolve this linear equation separately, and we'll resolve this equation as well separately. So from here, we have the square root of t. When this minus square root 3 crosses over to this, it becomes positive square root of 3. Now, taking the square of both sides, we're then left with t is equal to 3. So we've gotten the first solution. We'll then resolve this equation to get the remaining solutions. So resolving the next equation, we have t plus square root of 3t plus 3 equal to 0. For us to resolve this, we'll be eliminating this square root. So let's take t plus 3 equal to, we want to move this over to the right hand side. It becomes minus square root of 3t. We'll now take the square of both sides. Okay, square both sides. This will become t plus 3 all squared equal to minus square root of 3t all squared. So when we square this, we'll now be having t squared plus 2 bracket 3t plus 3 squared equal to, this square root will cancel this square root. We'll now be left with 3t. Negative times negative will vanish. So we now have t squared plus 2 times 3t plus 3 to the power 2 equal to 3t. So let's open this bracket. It will then give us 2t squared plus 6t plus 9. Bringing this back, we have minus 3t equal to 0. So this will become t squared 6t minus 3t plus 3t plus 9 equal to 0. So we now have a quadratic equation. So we can use the formula method to resolve this quadratic equation. Our a is equal to 1, the coefficient of t squared. Our b is equal to 3, the coefficient of t. And our c is equal to 9. So we'll now be using the formula method, which is t equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So let's insert these figures into the formula. We'll now be having t equal to, our b is 3, so minus 3 plus or minus b squared is 3 to the power of 2 minus 4. Our a is 1 and our c is 9 all over 2 times 1. Our a is 1. So t is equal to minus 3 plus or minus square root of 3 to the power of 2 is 9 minus 4 times 1 times 9 is 36 all over 2. So our t is equal to minus 3 plus or minus square root of minus 27 over 2. So t will now be equal to minus 3 plus or minus. This minus 27, we can actually break it into 2, which is 9 times 3 root minus 1. So we now have minus 3 plus 1. The 27, 9 times 3 times minus 1, square root of minus 1 all over 2. So t is now equal to minus 3 plus or minus square root of 9, square root of 3, square root of minus 1, all over 2. So t is equal to minus 3 plus or minus, so the square root of 9 is 3. So we now have 3 root 3i over 2. So t is equal to, so from here we've actually gotten the two values we are looking for, because we can no longer solve further. So we now have t is equal to minus 3 over 2 plus 3 over 2 root 3i. So this is t2. T3 equal to minus 3 over 2 minus 3 over 2